Hello and welcome back. A few weeks ago I received the laser engraver that I purchased, and since then I've assembled it and had a little bit of a play around with it, and everything goes pretty well. Currently the laser engraver is in my computer room, and the issue with that is there is no ventilation, and of course you get a bit of smoke from the laser engraver. So I'm going to build an enclosure and put the laser engraver up in the garage. And of course I'll record videos of doing that process and I'll post those at a later date. Now in today's video I'm going to be making a bowl from a board jig. And if you don't know what a bowl from a board is, it's basically cutting rings out of a board and then gluing them up in such a way that you form a bowl. And then of course you would finish turn the bowl on the wood lathe to make all the sides even. There are two main parts for this jig. One is the parting tool itself, and the other is the holder that you use to guide the parting tool at an angle to the board when you're cutting through the board there. Now that guide is kind of customly built to suit the parting tool that you're going to use, so I'll have to make the parting tool first. I'm going to have to make a new parting tool because my existing one is not suitable for this job. So first of all, it's a flat parting tool on the side, so you get a lot of friction in here and there's no relief on the sides. And the second issue, it's 5.5 millimeters or 732 thick, so you're cutting away a lot of the wood when you're cutting the rings out, and that can cause a few issues as well when you start gluing them all back together. So I'm going to make a parting tool out of this blade. So this is the same blade as what you would have seen on my spring parting tool video. And I don't know if you can see that, but it is tapered down here. And it is a very thin blade. So we're looking at 332, which is less than half of my traditional parting blade there. I'm going to use this 16 millimeter square stock here to mount the blade. The blade is 1/2 inch this way, so I'll be able to mill out a channel in here, and then I'll mount the blade in here. And what I plan to do is drill a couple of holes through the blade, and this is high-speed steel, so that might be a little bit difficult to do. Then we're going to put a piece of plate on this side with some threads in it, and I'll just bolt right through from this side, and that will clamp that blade in there. So the blade should be somewhere in the middle-ish. Now before we do that, this blade is tapered this way and it's got an angle on it that way as well. So I want to go over to the grinder first of all and just flatten these off so they're square with the back side, and then it'll only be the front side that is kind of tapered, and that should give me a nice wide area at the bottom here for it to fit in to the tool here and just rest on that bottom piece. I grind back both edges and it takes about 0.7 of a mil off of the width, so the width is now 12 millimeters. Here I'm marking out the bolt holes on the right third. The left third will be how much of the blade goes into the wood, and the middle third will be how much it moves within the jig. I need to drill 2 holes in this high-speed steel, and I'm going to use this piece of steel as a sacrificial parallel. I also need to mill it on an angle so that the blade is flat when I drill it. I true up the sides and then tidy up the ends as well. The angle of the blade is 3.1 degrees, so that's what I set the block up in the vise. And then that's milled across the top. And that gives me my angle that I need. The blade sits on the parallel like that. I don't have a 6mm drill to drill this out, so I start with this 8mm drill just to make a little divot. That will keep the next drilling process in the center there. Yes, you are right. That is a German-made masonry bit. Now I don't have a 6mm carbide bit to drill these holes, so I've tickled up the faces on this masonry bit, and let's see how it goes. Now most of that smoke is from the oil, but I do take it in little steps here. About 2 cuts for each hole. And that is frickin' brilliant. Now that the blade is complete, I'm working on the holder itself. I'm milling down about 2mm each side just to narrow this piece down a bit. Now I've got to cut the slot for the blade up at this end, and that's going to go down 7.2mm, and the width is going to be 12mm wide. And I'm just taking small cuts here, and then I widen the hole out just so the blade is a nice neat fit. While I have it all set up in the vise, I'm drilling out these two 6mm holes for the bolts. Here I'm doing a test fit up. Now I need to countersink these bolts. And test that out, and that is perfect. I start on the clamp, and this has been milled down to just under 12mm. I square the ends up, and this is important, you'll see a little bit later on. Here I need to drill out the 2 holes, and these 2 holes need to be tapped for M6 bolts. This is the reason why I had to square off those 2 ends so that I can put it in the vise. I'm cutting this on that 3.1 degrees angle to match the blade. The final step here is to round off the end to match the holder. Here I do a full assembly. I need to cut off that piece of the clamp and these 2 bolts here. And this is the finished product. Came out pretty good. Now I need to turn this end bit round so that I can put a handle on it. I've been looking at the handle for the tool, and there's a few options here. I have this carbide cutter where the shaft can be removed, so I could mill this down into a square and fit it into this one. So that's one option. The other option is to turn it round and make a wooden handle and then put it into a wooden handle. Another option is to turn it round and make up a round handle out of the steel. So there's 32mm steel and 24mm steel, but I think that's going to be quite heavy, even if it's just a short handle about, that long. And I guess the other option is to see if I can source some aluminium, maybe some 32 diameter aluminium, and make a handle out of that. Anyway, I'm going to think about that for a little while, and I'm going to carry on with the next step, which is making the guide. The guide is quite simple. It's just a piece that has a slot in it for the parting blade to go into. And it's angled at the front so that you can put this on an angle so that you can cut the rings out of the board. Now, Gary at the Papa 1947 YouTube channel is a great wood turner, and he does a lot of this board from a bowl type work and segmented bowls. And he actually made this board from a bowl jig here, and he's got another one that he made out of aluminium as well. But on his videos, which I'll link in the description, he's actually drawn up some plans, which is what you see over here, and I've just converted those to metric to suit the metric sized materials that I have here. I'm going to make this part out of this piece of 1" or 25mm thick steel here. So it'll basically just be that shape there. It'll be cut down on this side, just as you see in the picture here, and then it'll fit into a tool post with this 25mm round bar here. I've been looking around on the internet for different types of jigs to do this board from a bowl, and this one here looks to be one of the best ones and probably the easiest ones to make. So full credit to Gary from the Papa 1947 channel, and I do appreciate him posting up his plans and dimensions there for us to make this jig. I'd start by marking out the shape. This allows me to work out where I need to cut off the ends and the side. Then it's over to the mill and I square up this piece of metal. Wow, that was a waste of time doing that pretty drawing on there. So I drew on the pretty drawing again, and I have to remove this part with the X's down to this depth here. What is the best and most efficient tool for that? Of course, the angle grinder with a cut-off wheel. But that doesn't always work. I clean up the cut surface with a end mill. Here I'm very carefully cutting a slot with one side that has a 3.1 degree angle on it. Yeah, with the angle grinder. Well, the blade fits in there, but it's a little bit sloppy in there. Trying to get a 3.1 degree angle with an angle grinder, that's pretty hard. Anyway, move to plan B. I'm going to remove this side here, and then I'm going to make up a clamp that can be bolted on with a bolt and can be pushed up against the blade. I cut that side off with the angle grinder. Then I set up in the mill and I clean up those two surfaces so they're nice and flat and square. The blade fits in there like that. I have this 10mm piece which will be our clamp or guide. The edges and the ends get tidied up in the mill. Now I have it on that 3.1 degrees angle, and I clean up the surface. And when I put the blade in there and test it, that is absolutely perfect. There's no movement in there. Now I need to tack this piece on so I can drill a hole and put a bolt in there. Here I'm drilling out for a M6 bolt. I drill the tacked on piece 6mm so that I can get the tap in to tap the bottom piece to M6. Bolt it all down, and this is the area that we now need to machine up. I attack this side with the angle grinder, and that gets most of the material off. Then set up in the mill at 27 degrees. I had to be careful here because that piece is only bolted on. I didn't want it moving. So I made sure that every time I milled that piece, I was coming this way so that the milling cutter was pushing the piece towards the bulk of the other piece. Now we flip around and set up the other side to 27 degrees. Once that's been milled, I clean up the front part on the belt grinder. And that's the front of it all pretty much finished. And the blade fits perfect. There is very little movement sideways there. The bolt hole has enough clearance so I don't have to slot that out. The handle will come up to this line here. The line at the bottom is slightly to the left, about there. And I'm going to cut that bottom piece off on the right hand side. Then I need to drill a hole, well, in the middle somewhere, for the tool post. That gets dealt with the angle grinder. I tidy up the end in the mill. And here I'm drilling a 15mm hole, and the tool post will pop through there. Now we're working on the tool post in the lathe, clean up the end, and I'm cutting in around about 10mm, and I'm going down to 15mm to suit the hole that I drilled. I test the part and that works great. That's all pressed together and welded in place. That's pretty much done. I have this lock collar that I made a while ago, and that will be useful here. So I can set up the height on the center that I have in the lathe spindle, and then once that is all set, I can lock that lock collar, and that allows me to take it out and put it in, and I'm bang on center each time. Now we're back to the handle decision, and I found this bit of pipe, and what I'm going to do is turn this holder round, and then I'm going to make a bushing that will go in the pipe and around the holder, and then there will be 2 grub screws in there. The holder is rectangle, and I need to find the center here and drill it with a centering drill. That helps me dial it into the 4-jaw chuck using a dead center and a live center and a dial gauge. I turn that down until it is round. That looks great. I cut the tubing off to the right length and tidy up the ends in the lathe. Now I work on the solid metal part that holds the cutting tool. I take the outside diameter down, then I cut this smaller diameter which fits into the tubing. This almost fits. I think I'll be able to press this on. I use my ball peen press to push this piece in. I probably didn't need to weld this, and that bit that's held in the vise also gets cut off. The entire pipe is in the spindle, and I clean up the end. I take the outside down to the diameter of the pipe. Now I drill out and ream for a 12mm hole that will suit the cutting blade. This is a really good fit. I cut an angle on here, pretty much just for aesthetics. Then the same process for the other end at the back of the handle. Press it in, cut off the excess, and turn down the ends. And I'm putting a little bit of detail in here. So I'm cutting 3 little grooves. Again, aesthetics. I drill and tap for the 2 grub screws that will hold the tool in the handle. The last part is to polish it all up, and I sand this all the way up to 320 grit. Now the tool itself needs a flat on it for those grub screws to clamp down onto. And it goes together just like that. And that's the cutter all complete. I've done a little bit of testing off camera, and this works really well. This is a spindle. It's not really what the tool was designed for, but it's just what you do when you're cutting off a spindle in the lathe, and the tool just mows into it, no problem at all. Now I've set up to cut a ring out of a board here, and I'm using this 45-degree angle first up. Again, this goes in really easily. I didn't quite know how far in I was, so I come out and just have a quick look. There's a little way to go, and that pops off. Now I've got to either remove the chuck or remove the part in the chuck to get this ring out. I've set up for the second ring. This is at 55-degree angle. And if you haven't noticed already, this guide is a little bit too far away from the board, and I sort of bottom out here where I can't push the tool any further in. Took me a few seconds to figure out what was going on. I've adjusted that and we're back into it. That ring pops off. Again, I have to take the wood out of the chuck to get the ring out. Well, there you go. I cut some rings out of this board and the jig worked really great. So these rings would be then glued up in such a way like this, and then it would be turned properly into a bowl. Now this is only a bit of scrap wood. I think it's pine, you can tell by the very wide grain, but the cutting angles that Gary suggested are really good and they come out almost bang on here, so I'm pretty happy with that. Now you might have noticed I didn't use the 60-degree angle, and I think that's because the piece of wood I started with was not a very big diameter. So if I used a 60-degree angle, I would have cut through here and probably right into the center of the tenon. So I didn't actually do that this time, but maybe on another test I'll do it on a larger board, and then I will probably be a little bit bigger in diameter when I get to this piece, so I'll be able to come through maybe down here somewhere. The jig guide came up really good as well. The blade slides in here nicely. There's no problems with this at all. It's supported or welded here, so that's going to be really, really good to use on a real job. And the cutting bar that I made is really good as well. Possibly the only change I might need to make is to make this blade a little bit more narrow here. The cutting that second ring, there's quite a lot of kerf in there, so it's because the blade is quite long this way. I think it's about 12 millimeters now, and I think Gary was saying that you should have about a 1/4 inch, was just over 6 millimeters, so I might need to cut a little bit off there, but I'll do some more testing and I'll see how that goes. And once I've done further testing, I'll do a video on a proper bowl, and then you'll see a bowl being cut out of the board and glued up and finished turned and completed. This was a really fun project to do, and I got to give a shout out to Gary from the Papa 1947 YouTube channel for the help and advice he's given and the plans that he provided. So thank you very much. And to everyone else watching, thanks for watching.